Alright, so I wanted to show a quick example of using the Pythagorean identity, and I also wanted to talk about how we know when our trig functions are positive and when they're negative, based on where they are on a Cartesian graph. So we're going to talk about both of those things really quickly. First, I want to work through a quick example of using the Pythagorean identity. So in this question here, it says angle theta 1 is located in quadrant 2. So let's go ahead and draw our coordinate graph. And remember, our quadrants are labeled 1, 2, 3, and 4. So they go counterclockwise around the regular XY axis. So here's the x-axis, here's the y-axis. So we're in this quadrant right here. We're in quadrant 2. And we have some angle theta. And we know that the cosine of that angle is negative 2 over 11. So let's go ahead and write our Pythagorean identity out. So the Pythagorean identity is that sine squared of theta plus cosine squared of theta is equal to 1. All right, that's our standard Pythagorean identity. Remember, there's two others. I'll write them really quickly. We have tangent squared of theta plus 1 equals secant squared of theta, and we also have 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. So these are our other two trig identities, or our other two Pythagorean identities. We're not using those in this problem, but I just wanted to point those out. Those are the other two important ones. But let's go back. We're dealing with this one right here. So we are given cosine of theta. So I'm just calling theta 1 theta. I just changed the variable to make it easier to write. So sine squared is what we're solving for. We don't know sine squared. But we do know that cosine of theta is negative 2/11. So cosine squared of theta is just going to be negative 2/11 squared, right? So this squared right here means that we're squaring the entire function. So I just moved the square to the outside. It means the same thing. So that's all equal to 1, okay? So now I'm just going to solve for sine of theta from here. So first thing I want to do is, there's a couple ways you can do this. I'm going to go ahead and square this. So I'm going to make this, so negative 2 squared would be 4. Remember, if I square a fraction, I'm just squaring both sides. And then 11 squared is, I believe, 121. Should probably check that. Yes, 121. So this is equivalent to 4 over 121. Since it's a negative and it's being squared, a negative times a negative becomes a positive. So my new answer is positive. And that's all equal to 1. So sine squared of theta is equal to 1 minus, so I'm going to subtract 4 over 121 from both sides in order to get sine by itself. So sine squared of theta is going to be, and the way that I normally do this is I think of 1 as 121 over 121 to get my common denominators. It's impossible to subtract those fractions unless I have common denominators. And so now 121 minus 4 should give me 117. So sine squared of theta is equal to 117 over 121. Now, that's not the answer, though. The answer is asking me for sine of theta. So sine of theta, this is sine squared of theta. So to find the sine of theta, I'm going to take the square root of both sides. So I'm going to square root both sides. So that gives me that sine of theta is equal to square root of 117, which is not a nice round number, so I'm going to leave it as square root of 117. Square root of 121, though, we just found out from up here is going to be 11. 11 squared was 121, so the square root of 121 would be 11. So my answer for this one will be the square root of 117 over 11, except there's one other thing I have to think about. So in the second quadrant here, all of my cosine values are negative, and all of my sine values are positive, and I want to talk about why that is. So in this case, the answer actually is the positive square root of 117 over 11. But remember, when I take the square root of anything, I can have a plus or a minus answer. So let me write that out here instead. So I can have a plus or a minus square root. So in this case, we're using the positive answer, but let me show you why that is. So scroll down here, look at our unit circle first. So on the unit circle, remember that our x values are always corresponding to the cosine of the angle that we're looking at. So if theta is right here, the x value of this point on the unit circle is equal to the cosine of that angle. So our x values are always cosines, and our y values are always the sine of the same angle. So the y value at this point, which is 1/2, is the sine of theta. So sine of pi over 6 is 1/2. That we know that's true. X, the cosine of pi over 6 is the square root of 3 over 2, which we also know. This is one of our reference triangles or our special right triangles. So in the same way, when we look at, say, quadrant 2, all of our x values, so all of the x values for each of these fractions is negative. That's because any x value to the left of the y-axis is always negative. So our x values are negative. However, in the second quadrant, all of our y values are still positive, and that makes sense because all of our y values above the x-axis, so all the y values in this quadrant are going to be positive. Down here, both are negative. So all of our x values are negative, and all of our y values are negative. Well, 0 can never be negative or positive, it's just 0. But the others are negative. And that's because all of our y values are below the x-axis, so they're all going to be negative. And all of our x values are to the left of the y-axis, so they're all also going to be negative. Oops. And then finally, if we keep going around, all of our x values in the fourth quadrant are going to be positive again because we're to the right of the y-axis now. So we're in the positive x direction, so all of these are positive. However, all of our y values are still negative because we're still beneath the x-axis. So all of our y values down here are still negative, and all of our x values are positive now. So that's just how we normally think about graphs, right? We think about positive x, positive y, and we know where the negative x and y values lie. When we're talking about with trig functions, it works the same way because remember, again, our x is correspond to our cosines and our y's correspond to our sines. And then remember that, let me get a different color altogether. Remember that tangent of theta is equal to the sine of theta over the cosine of theta. So tangent will be negative if one of these is negative, if sine is negative but cosine is positive, or if cosine is negative but sine is positive. So we get negative tangent when one of these is negative, either this one or this one, or this one is negative. That's not a great way to write that, I guess. But however, if they're both negative or if they're both positive, then we get a positive tangent. So tangent is positive even if both of these are negative. A negative divided by a negative gives me a positive, so that makes them positive tangent. If they're both positive, then we still have a positive, right? A positive divided by a positive is still a positive. So if we're thinking about this in terms of trig functions, one of the mnemonics that people often use, let me move this over just a little bit, to remember this is the mnemonic ASTC. So I've heard this used in a lot of different ways. I've heard all students take calculus, which isn't always true, so I don't love that one, but it worked. It fits the mnemonic. I've heard all science teachers are crazy. I've heard add sugar to coffee. There's other ones, and I'm sure you could think of your own if none of those really stick in your head very well. But the idea is a way to remember which trig functions are positive in which quadrant. So I'm going to go through that and show you what I mean here. So let's label our quadrants. So we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And so in the first quadrant, what the A stands for is all. So all of our trig functions are positive. So sine, cosine, tangent, and all of their reciprocals. So and cosecant, secant, and cotangent. All 6 of these are positive in the first quadrant. No matter which one you're looking at, it's going to be positive. And you can think about that because the sine and the cosine, the x and the y are both positive, and all of these somehow depend on sine and cosine. So if sine and cosine are both positive, that means tangent, which is sine over cosine, has to be positive. secant, which is 1 over cosine, has to be positive. You know, cotangent is the inverse of, or the reciprocal of tangent. That also has to be positive. They're all positive. In the second quadrant, however, that's what the S comes in. The S stands for sine. So in this quadrant, only the sine and its reciprocal, so the ones associated with sine, directly associated with sine, are positive. So in this case, we have sine is positive. However, cosine, tangent, secant, and cotangent are negative. And if sine is positive, that means cosecant has to be positive, because cosecant is just the inverse, or the reciprocal of sine. So if sine is positive and cosecant is just 1 over sine, then if sine is positive, cosecant has to be positive, no matter what. This 1 is always positive, so then this has to be positive as well. So in the second quadrant, our sine and its associated reciprocal cosecant are both positive. In the third quadrant, the T stands for, you can probably guess, tangent. So in the third quadrant, only our tangent and its reciprocal are positive. So our sine, cosine, cosecant, and secant are all negative. And the only positive trig functions in the third quadrant are tangent and cotangent. And again, that's because if sine and cosine are both negative, then a negative divided by a negative will give you a positive tangent. And if tangent's positive, the reciprocal of that will still be positive. And then lastly, in our fourth quadrant, the C in this mnemonic stands for cosine. I'm sure you saw the pattern already. So if cosine is positive, that means only cosine is positive in the fourth quadrant. So sine, tangent, cosecant, and cotangent are all negative, and only cosine and secant are positive. Now that's just a way to remember which are positive in which quadrant. Personally, I just visualize the unit circle and I think about, okay, if the x values are negative in the second quadrant, that means anything with a cosine in it is going to have to be negative. Whichever way works better for you to remember it is fine. It doesn't matter if you remember it using this, or if you visualize the unit circle in your head, or if you come up with a different way to remember it. It really doesn't matter to me how you remember it. I'm just trying to show you a different way of thinking about it. And the last thing I wanted to talk about is sometimes they won't tell you explicitly that an angle is in quadrant 2, for example. They might tell you instead that, let's say that they say theta, they'll probably say pi over 2 is less than theta is less than pi. What this means is that theta is between pi over 2 and pi. So if theta is in between pi over 2 and pi, we know that pi over 2 is right here at on the y-axis at 90 degrees, and pi is right here on the negative x-axis at 180 degrees. So we know that still has to be within these bounds. It's still the second quadrant. This is still quadrant 2, but they didn't tell you explicitly it's in quadrant 2. They just told you which angles the theta had to be between, and then you figured out from there which quadrant it's in. So if they were to tell you that pi is less than theta is less than 3 pi over 2, that would indicate that theta is in the third quadrant, somewhere between pi right here, right here, and 3 pi over 2, which is down here. So that would mean in the third quadrant, but they don't explicitly say it that way. So just a couple things to keep in mind as you're doing the rest of your Khan Academy and studying for the remainder of the unit. So if you have questions on that, please let me know, guys. Thanks for your attention.